Hello everyone, welcome to BLAR12041 Building Materials 2. This is Pen and I will be your lecturer and course coordinator for this course. I have recently joined the university as a full-time lecturer, and hopefully that we can both learn a lot by interacting with each other during the semester. For more information about me, such as my availability, please visit About the Lecturer in the Moodle site of this course. This course covers 12 topics. Each topic will be recorded and posted online so that you will have clues how the textbook, reading materials, and additional readings are linked together. You will need to participate online through the forums. Bonus points may be given to students who are very helpful in answering other students' questions in help delivering the courses. I will post articles to the forum regularly for you to read, and please do read them. You will need them for your assessment items. There are 3 assessment items in this course, and there will be no exams. For more information, please visit About the Assignment in the Moodle site. As stated, there are 12 topics in this course. We will discuss one topic every week, and the review session will be organized after the 12 weeks. There are 3 important dates that you should remember and mark them on your calendar. These are the due dates for the 3 assessment items. I will mark these in the calendar of the Moodle site, and I will remind you when we are approaching these days. Please remember that only electronic submission, including Word document and PDF documents, is allowed. One file in most cases, please. Don't submit after the due date. Late submission will be penalized for 5% per day. You should also know the consequences of plagiarism. I have posted a few links to the university resources, such as what is a plagiarism and how we can avoid it in the Moodle site. Please do have a look. This course is not only about teaching you the building materials, but more importantly, I think is how to find related resources to address a problem, and how can we cite those references in an academic way. So topic 1, environmentally responsible selection of materials. There are 3 important aspects that will be discussed. Why we are doing this, and how are we doing this, including a general procedure and a calculation method. Why do we need environmentally responsible selection of materials? It is basically driven by the rising recognition of the concept sustainable development, which is to meet the needs of the present without compromising the ability of the future generations to meet their own needs. The negative impacts we have caused the Earth, including global climate change, as we all know, sometimes it is called global warming, and resource depletion, waste and pollution. Building industry, as one of the most polluting industry, should act responsibly by choosing environment-friendly building materials. This can be completed by using life cycle assessment. Life cycle assessment is a methodological framework to estimate and assess the environmental impact of the life cycle of a product, such as we can assess the climate change. If we have 2 similar products, let's say one which generates 200 kilograms carbon emissions in its life cycle, and the other generates 300 carbon emissions kilograms. Basically, we choose the first one. This is just a simple case, and in reality it's more complicated than that. So what is life cycle? Now if we arranged by time, the materials have to be acquired from the earth, delivered and manufactured for use. After that, it will be shipped to the construction site for use and maintenance. And when, after several years and decades, some of them can be reused, recycled, such as steel. Some of them are just disposed, such as concrete. Now, when arranged by importance, the construction, use, and maintenance is the most important one, and after that, manufacturing and fabrication, and then material acquisition, and the least important one is reuse, recycling, and disposal. Now, in the construction, use, and maintenance stage, the first questions you need to ask is, will the material have a measurable impact on building energy use? Now, basically, we should avoid options that have a huge impact on the building energy use and choose options that have a relative small impact. Question 2. Might products in this application affect the health of building occupants? Now, it is important for us to avoid those that have adverse effect on the occupant health, such as some painting materials. Question 3. Are products in the application likely to need replacements or repair? The general rule is that we should avoid products with short expected life cycles. There are other strategies that can be taken. Please refer to the building materials. In the manufacturing and fabrication stage, there are 3 questions that should be asked. Number 4, are significant byproducts created during manufacturing? If this is the case, the material should be avoided. And how energy intensive is the manufacturing process? The general strategy is to avoid the materials with high energy intensive manufacturing process. I will explain to you how to calculate the energy. How much solid waste is generated in the manufacturing process? If there is a significant amount of solid waste generated, and these cannot be used for other purposes, and the strategy is to avoid the material and seek another product. In order to calculate how energy intensive the manufacturing process is, there is this concept called embodied energy that you should understand. The embodied energy of a building material can be taken as a total primary energy consumed over its life cycle, including extraction, manufacturing, and transportation. There are 3 possible ways to do this. The first is a process analysis. The process analysis is to calculate the embodied energy from extraction to end use. In order to do this, you first need to draw a process tree about how the production is organized or how the product is manufactured. Now, in each of the sub-process, for example, all these circles, you will have to record the energy consumption. Then we'll have to add all the energy consumption in these circles up to get the embodied energy for the product. This is called a process analysis. There is another method called input-output analysis, which is to use national average data for each sector of the economy. However, since we're using national average data, this may not result in the valid results for a particular product. And the third method is a hybrid analysis, which combines the process analysis and input and output analysis. In the material acquisition preparation stage, There are 3 questions you should ask before you choose the material. Question number 7. Are any of the component materials from rare or endangered resources? If so, avoid the material and choose another option. Number 8. Are there significant ecological impacts from the process of mining or harvesting the raw materials? If it is, then avoid the option. Are the primary raw materials located a great distance from your site? The general strategy is to choose material from a nearby manufacturer. This will reduce your transportation distance and reduce your energy consumption. Reuse recycling is more and more important in the construction industry because this will save your energy consumption. So the question you should ask is, can the materials be easily separated out for reuse or recycling after its useful life? And might the material become a toxic waste problem after the end of its useful life? And for all the questions you have asked, are there anything that you have missed? If so, add the questions to the list, such as question number 13. Reuse recycling is more and more important in the construction industry. Materials with high levels of recycled content will have few manufacturing impacts, since it has already been manufactured, and it requires less extraction and has reduced impact on landfills. However, it should be noted that the potential hidden costs in recycling or reuse shall not be overlooked. For example, in order to recycle or reuse steel, we will have to heat the steel to a certain temperature, and by heating, we need energy, and that energy is a hidden cost of the recycling or reuse. This table gives you a few typical impacts and strategies to deal with the impacts. For example, in distribution and transport, the typical impacts is fuel use and air pollution, and the strategies is to purchase local materials and avoid unnecessary transport. The workbook activity for this week is environmental impacts of transport in materials production. You will have to identify a product such as PVC and find its source, its manufacturing plant, and a hypothetical retail sales point, and you will have to calculate the environmental impacts, for example, the carbon emissions. This is the end of the lecture. If you have any questions, please feel free to contact me, and please post it to the general forum. If it is private, then send me an email.